Okay, sir. Now we will explain the other networks, the IEEE 33 and IEEE 14 in the general case. As you see here, the same thing, the load data, the line data, as you see here, the main program. The main program, it is to call the binary PSO and the load flow, and then printed the result, the same thing. And to figure the compare between the voltage and the voltage base profile. And this is the program put it the voltage base profile that we get it from the base case. And the same thing, the PSO, the same thing of the IEEE, as you see here, the definite problem definition, PSO parameters, and then we velocity limit, initialization, then this is the initial process. And after that we started the main program or main loop of the PSO, repeated this process for the maximum iteration, updated the velocity, apply velocity limit, updated the position depending on your equation, reference equation, and then applied the position limit, evaluation the cost, and then updated the personal best and updated the global, and repeated this process for the maximum iteration. And after that we printed in each iteration the best value that we get it, and then we stored the best value, global best, in the best solution. And after that we printed the how the behavior of the best cost with the iteration. This is the PSO, and the same thing, it is the load flow, two things that the preparation generation, as you see here, and the calculating the object function for the load flow. And then we printed, after we run it, we get it like this. This is printed the best fitness value that program get it in each iteration, and then we printed this result. This is the result. It is the size of the distributed generator, the location, the capacitor and the location of capacitor, and the fitness value that we get it. And after that, the network result, it is the power loss, reactive power loss after compensation, voltage profile after compensation, reliability index after compensation, energy not supplied after compensation, minimum voltage after compensation. And you can see also the how the graph, this is the graph, the behavior of a graph of the voltage between the base case and the PSO case. As you see here, the PSO, it is near to the 1 per unit than the base case. That means the voltage curve, it is for the each bus, it is better than the base case for the PSO case or compensation case. Then also the same thing for the IEEE 14 bus. As you see here, if you go the same thing, for all thing, we can run it as you see here, but and we waited after the program finished, and then we will print it the result and explain the result. And as you see here, we have the base voltage profile for the base case, and the binary PSO program, and the base the main program of the PSO, binary PSO, and the data of IEEE 30, and the load flow program. And it is the same thing, the same changing to allocated the distributed generation and capacitor. As you see here, we have, this is the voltage profile figures. As you see here, in the PSO, it is near than the red one, it is the base case. This is so the voltage curve of the compensation case, it is better than the base case, as you see here, because it is near than the per unit or operating voltage. And when the curve, it is near that the operating voltage 1 per unit, that means the system, it is better than the others. And if you see here also, you can see the graph that operating, and as you see here, it is the result in the IEEE. You can see the size of distributed generation, location of distributed generation, the capacitor size and location of capacitor, and also the network power loss, reactive power, voltage index after compensation, all this data after compensation. So we hope it is clear for you for the explanation for all network. This is the last videos for explanation. If you have any question, as we mentioned before, you can ask us and we will help you or answer you what is the unclear idea for for our code, and if you have also any misunderstanding, you can ask us. Thank you very much, and we see you later, inshallah.